Hello, we will continue this EPA 608 Universal Certificate Type 3 leak detection. Now we finished the introduction in the last video. Now we will continue leak detection, leak on low pressure system. Let's see it.
In this module, we will learn about leaks in low-pressure systems. We will see the different indicators of a leak and the common areas that can leak in a Type 3 system.
It's important to remember that matter tends to flow from areas of high pressure to low pressure. When dealing with a leaking water pipe, you typically observe water escaping from a visible opening. However, in the context of low-pressure appliances, leaks may not manifest in the same visible manner. Remember that a low-pressure system, like Type 3 appliances, functions below atmospheric pressure, essentially creating a vacuum environment. In such systems, the vacuum effect operates similarly to a vacuum cleaner, exerting a pulling force. To prevent unwanted moisture or contaminants from being drawn into the system, it's crucial for Type 3 appliances to maintain a tight seal. Water flows through the evaporator and condenser of chiller systems as part of their operation. This water can inadvertently leak into the refrigeration system and mix with the refrigerant. Additionally, outside air containing non-condensable substances may also seep into the system. Moisture, classified as an impurity, is categorized as a non-condensable substance within the system. Air, moisture, and nitrogen are also examples of non-condensable gases commonly found in any system. When there are issues with sealing low-pressure systems, it allows outside air and moisture to infiltrate the system, potentially leading to operational issues. Head pressure, often referred to as high side pressure or discharge pressure, represents the pressure exerted on the discharge side of a system where liquid refrigerant is present. If the discharge side pressure in the refrigeration system is elevated beyond normal levels, it can indicate the presence of non-condensable gases. The reason for a higher discharge pressure is the gases in the system remain in the vapor phase and do not convert to liquid form. This vapor exerts pressure on the refrigerant liquid, resulting in an increase in pressure on the discharge side of the appliance. The function of the purge unit is to remove moisture collected within the refrigeration cycle. If there is excessive moisture accumulation in the purge unit or if the purge unit is running excessively, it could indicate a potential leak in the system. Excessive moisture collection in the purge unit could indicate that the condenser or the chiller barrel tubes are leaking and drawing water into the system. Water tubes in the chiller that suffer from leaks may need extensive repairs.
The purge. Now, on these units, the purge, which is over here, is used to remove any air or contaminants that get into the system. The evaporator is generally in a pressure less than atmospheric, so it's in a vacuum, especially while it's running. Because of this, air will get sucked in, and we need some way to remove it. So we use the purge. It's a refrigeration unit that takes the air and refrigerant samples off the condenser, normally, condenses the refrigerant, puts it back into the evaporator, and relieves the non-condensables either into a regenerative container so we can clean it out some more, or vents it out into atmosphere because it is not a refrigerant, it is non-condensables. Does a great job of removing those non-condensables. So one way we look for leaks on a low-pressure machine is looking at what our purge rate is. How many times an hour or a day I'm actually purging.
Continuous excessive moisture collection in which component of a low pressure refrigeration system could indicate leak. Okay. Water box per unit, drain valve outlet per unit. Yeah.
In a belt-driven non-hermetic system, the compressor motor and the compressor are housed in separate structures and connected by a rubber belt. Unlike the hermetic type, which encapsulates all components within a single shell, this configuration allows for easier maintenance and repair. These systems are commonly found in industrial refrigeration applications due to their robustness and versatility. A rotating shaft seal is used at the junction where the metallic shaft connects to the compressor. These seals typically feature rubber components designed to provide effective sealing. However, if a system remains inactive for an extended period, such as several months, the rubber seals may harden and lose their ability to maintain a proper seal, resulting in potential leaks within the system. To reiterate the whole concept, a rotating shaft seal is used at the junction where the metallic shaft connects to the compressor. In a belt-driven non-hermetic system that has not been used for many months, the rotating shaft seal is most likely to leak.
Which part of belt-driven non-hermetic compressor is most likely to leak if compressor has not been used for several months? Rotating shaft steel.
Fittings generally refer to any component of the piping system that connects to the refrigerant tubing. This category encompasses nuts, joints, bends, elbow joints, and other pieces of refrigerant piping. Leaks may occur as a result of improper assembly of these fittings or due to damage incurred over time. A gasket typically consists of a ring made of rubber or another material, commonly observed in items like pressure cookers. These gaskets serve to seal the joint between two surfaces in various appliances, ensuring a tight and leak-free connection. However, if gaskets become worn out or damaged, they may no longer effectively seal the joint, leading to potential leaks. A water box is usually attached to the chiller barrel, sealed with gaskets. Similarly, gaskets are used in compressor parts for sealing. Both gaskets and fittings are common sources of leaks if not sealed properly.
On low pressure chillers, water is most likely to leak into the refrigerant system through air leak in the repetcher disk assembly, tube leak in the evaporator, leak from area with gasket or fitting. Yeah. Sorry.
In this module, we went through the definition of leaks in a low-pressure system. We also learned about the indicators of leaks and the common areas that can face leaks in Type 3 systems.
Leak detection. This in type 3 leak detection.
In this module, we will learn about the methods to detect leaks in low-pressure systems.
Low pressure systems.
Here's the list of leak detection methods we will discuss in this module. Vacuum testing, hydrostatic leak testing, using a leak detector probe, temperature-dependent leak test, and nitrogen pressure test. Vacuum testing involves using a vacuum pump to create a vacuum inside the system and test for leaks. A vacuum pump is the same equipment used during evacuation of a system. We will discuss evacuation in the upcoming topics. In general, we vacuum a chiller system to 1 millimeter of mercury and maintain this vacuum for a few minutes to observe if the pressure rises. According to ASHRAE Guidelines 3, if the pressure in the system rises from 1 millimeter of mercury to a level above 2.5 millimeters mercury during vacuum testing, the system should undergo further leak checking.
According to ASHRAE Guideline 3, the system should be checked for leak if during standard vacuum test the pressure in the system rises from 1 mm HD to level above above 3 mm, no, above 2 mm, 2.5.
Seal one end of your tube with a snap-type tube plug and easily tell if you have a leaky tube. A steady vacuum gauge reading indicates a good tube. If the gauge falls, you have a leaky tube. Thomas C. Wilson also has tube plugs available in all materials and sizes for any leaky tubes.
A hydrostatic test is a method used to detect leaks in oil pipelines, gas cylinders, boilers, chillers, and fuel tanks. In the process of the hydrostatic test, the tube of the chiller is filled with colored water. The water is pressurized above the operating pressure of the equipment. The pressurized colored liquid is held in the system for a set duration. Any leaks in the system will cause the water to ooze out of the leaking gaps or holes. The colored dye leaves a mark, aiding in visually identifying the location of the leaks. To summarize the process, colored water is pumped into the chiller tubes. The water is held in the tubes for some time. Leaks are detected by searching for colored watermarks outside the tubes.
There are many traditional methods for detecting leaks. Most require a lot of time and effort and aren't always 100% reliable. Fluorescent leak detection is a simple, fast, and highly effective solution that will help complete your leak detection solution routine. The process is simple. The technician injects the fluorescent dye at the low side of the unit. While the system is running, the dye starts to circulate throughout the unit. The technician then scans the system with a violet or UV lamp. The dye will be glowing at every leak site. The dye refrigerant mixture circulates and accumulates even at pinhole leak sites. When scanned with a UV light, it's easy to spot where the dye is leaking from, and the dye can remain indefinitely in the system to quickly identify any future leaks. Some of the many fluorescent leak detection benefits include universal use. It's compatible with all refrigerants and lubricants in residential and commercial systems, detecting small, multiple, and intermittent leaks, even at a distance, with the system off or running, remaining safely in systems and cutting emissions released, seamlessly implementing into a preventative maintenance program, and reducing contract service costs and callbacks.
What is the purpose of hydrostatic tube test kit? To determine if the tube leak? Yeah.
A leak detector probe is a device used to sense the presence of refrigerant outside the system. It is positioned near the opening of the drain valve of the water box of the chiller to inspect for refrigerant gas leaks. If refrigerant has leaked into the water system, it can be detected at the drain valve. After draining the water from the system, no discharge should be observed from the drain valve. However, if there is a leak, the leak refrigerant may find its way to the drain valve. This can be detected by positioning the leak detector probe near the valve.
Where should a leak detector probe be placed to check for gas leak into the water box when water is removed? Okay. Where should leak detector probe be placed to check for gas leak? At the ruptured disc seal, around the vent valve, around the test plug, and the drain valve opening. Okay. around the test valve, I don't know. Around vent valve, no. To check the if gas leak into the water box with water removed, the leak detector probe should be placed in the drain valve. Oh, opening.
In this test, the pressure of the chiller is increased while it is working to detect any leaks in the system. To increase the system pressure in a controlled way, we use hot water or electric heating blankets. It's important to note that as the temperature increases, the pressure also increases. Electric heating blankets produce warmth by passing electricity through them. The gradual increase in temperature helps to avoid temperature shock to the evaporator. Similarly, hot water is circulated throughout the system in a controlled manner to increase the pressure of the system. The hot water also increases the pressure in the system. This increased pressure causes the liquid to ooze out of any leaking areas, if present, allowing them to be detected. However, it's important to note that the rupture disc on the evaporator may open if the pressures are raised too high, so this process must be done in a controlled manner. An electronic leak detector can then be used to detect any refrigerant leaks outside the system. In a nitrogen pressure test, also known as a standing pressure test, nitrogen gas is filled in the system to check for leaks. However, there is a drawback of using dry nitrogen to increase the pressure of the system for leak detection. This is because nitrogen gas cylinders are highly pressurized. While leak testing a low-pressure chiller with nitrogen, the maximum pressure should not exceed 10 psig. If it exceeds 10 psig, the rupture disc will burst open. Therefore, the nitrogen pressure test has to be conducted in a very controlled manner, which requires highly trained technicians.
When leak testing a low pressure refrigeration system with nitrogen exceeding blank psi could cause the to fail. 30 psi condenser tube, 30 per unit chilled, 10 ruptured disk, 20 evaporator. I think no, 30 condenser. Which leak testing a low pressure chiller with nitrogen, the maximum pressure could not exceed than 10 psig. Okay, if it's exceeding the rupture disk, the rupture disk will burst open. So the maximum for nitrogen 10.
In this module, we went through the methods of leak detection for a Type 3 system.
When leak testing low pressure refrigerant system with nitrogen exceeding than 10, okay, the rupture disk will,
In this module, we went through the methods of leak detection for a Type 3 system.
okay, it's going again to 22. Okay, so we finish this one. Let's go to leak detection, type 3 leak detection quiz. We have 7 questions. What is the purpose of hydrostatic tube test kit? To determine if tube leak, to blow all water out of tube, to remove water from machine, to vent refrigerant to the atmosphere. To determine if tube leak, where should a leak detector probe be placed? To check the gas leak into the water box with water removed in the drain valve opening. Continuous excessive moisture collection in which component of low pressure refrigerant system could indicate leak. Moisture in water box per unit, drain valve outlet, pressure relief valve. Continuous excessive moisture collecting in which component of low pressure refrigerant system could indicate leak? I'm not sure of this one. Drain valve outlet, I think. According to ASHRAE guideline 3, the system should be checked for leak if during the standard vacuum test the pressure in the system rises from 1 millimeter Hg to what level? To 2.5. When leak testing a low pressure refrigerant system with nitrogen exceeding than 10 psid could use rupture disk to fail. On low pressure chillers, water is the most likely to leak into the refrigerant system through air leak in rupture disk assembly, tube leak in evaporator, leak from areas with gasket fittings, leak from charging surface. Leak from areas with gasket. Which part of belt-driven non-hermetic compressor is most likely to leak if the compressor has not been used for several months? Suction surface valve, rotating shaft seal. Let's check the answers. Let's submit. 8.7. Let's see. This number 3 is wrong. Continuous excessive moisture collection in which component of low pressure refrigerant system could indicate leak? Purge unit. Okay, so we finish here. Type 3 leak detection with the quiz also. We'll go to the next module, this leak repair.
In this module, we'll delve into the EPA's classification system and define leak rates for specific systems. We will also learn about the process defined by EPA for repairing leaks in Type 3 appliances.
Many types of chiller systems are used in the market today. The EPA categorizes these various systems into 4 distinct categories. The systems are classified based on the purpose they serve. They include comfort cooling systems, commercial refrigeration systems, industrial process refrigeration, and all other appliances. Let us have a look at each category. Comfort cooling systems are designed to provide cooling and humidity control in spaces primarily occupied by humans. Examples of locations where comfort cooling systems are commonly found include residential houses, offices, and commercial office buildings. Chillers typically fall under this category of comfort cooling systems. Commercial refrigeration systems are appliances used in retail food and cold storage sectors. Some examples include supermarkets, restaurants, other food service chains, convenience stores, and cold storage to store goods like meat and dairy products. Industrial process refrigeration is directly linked to industrial processes. These systems are complex, customized systems used in the chemical, pharmaceutical, petrochemical, and manufacturing industries. This sector also encompasses industrial ice machines and appliances utilized directly in electricity generation, as well as ice rinks. It's important to note that if an appliance serves both industrial process refrigeration, IPR, and other applications, it will be classified as IPR equipment if 50% or more of its capacity is dedicated to IPR systems. The leak rate refers to the rate at which an appliance is losing refrigerant due to leaks. Based on the classifications provided in the previous slide, the EPA defines maximum leak rates for these systems. It's important to recognize that no appliance can be made entirely leak-free. Despite efforts to prevent leaks, all systems may experience very small leakages. These minor leaks are considered acceptable as long as the leak rate does not exceed the maximum leak rate set by the EPA. The maximum leak rate is the threshold above which the system must undergo repairs for leaks. It is also referred to as the trigger leak rate or threshold leak rate. It's important to remember these names when discussing leak rates and compliance with regulations. The following are the maximum leak rates for a 12-month period. Comfort cooling systems, 10%. Commercial refrigeration, 20%. Industrial process refrigeration, 30%. All other appliances, 10%. The leak rates listed in the table represent the maximum leak rates established by the EPA. These rates apply to all systems containing 50 pounds or more of refrigerant. If a system's leak rate surpasses the maximum leak rate specified in the table, it must undergo repairs for leaks in accordance with EPA regulations.
What category of leak repair does the EPA design assign to chiller appliances utilized in the retail food and cold storage warehouse sectors? It's commercial refrigeration. A company uses chiller that diverts 55 of its cooling capacity to its manufacturing, so manufacturing it will be industrial.
Refrigerant charge is the total amount of refrigerant in the system. It is necessary to know the refrigerant charge while calculating the leak rate and filling the system with refrigerant. For any Type 3 system, the maximum amount of refrigerant for that system can be found on the nameplate of that system. Topping off means adding additional refrigerant to the appliance without checking for and fixing any leaks. While topping off refrigerant in any system containing more than 50 pounds of refrigerant, it is compulsory to calculate the leak rate first. Seasonal variance involves adding or removing refrigerant from an appliance in response to changing external environmental conditions throughout different seasons. This adjustment of refrigerant is necessary to maintain optimal performance and efficiency of the appliance. It's important to note that calculating the leak rate is not necessary when adding refrigerant for seasonal variance.
Which of the following scenario triggers the requirement to calculate the leak rate for chiller containing 500 or more pounds of an ozone depleting refrigerant? Okay, following a retrofit during the installation of the new appliance during a qualified seasonal variance. I think during the when to open up the system.
Now that we are aware of the maximum leak rates for all types of appliances, it is important to repair any appliance that leaks beyond the specified maximum rate. If an appliance has a leak rate higher than the maximum leak rate set by EPA, the owner of that appliance has the following options: to repair the appliance, to mothball the appliance or the specific leaking components, to retrofit the appliance, or to retire the appliance. Let us look at each of these options in detail. After detecting a leak in an appliance, the owner must arrange for the leak to be repaired. Following the repair, it is mandatory to verify the results to ensure that the system is no longer leaking. The EPA mandates that 2 leak verification tests are necessary after repairing an appliance. A leak verification test involves a series of steps to confirm that the appliance's leak rate is below the maximum allowable limit. The 2 leak verification tests are: initial leak verification test. This test should be conducted immediately after the leak is repaired and before refilling the system with refrigerant. Follow-up leak verification test. This test should be performed after the appliance has returned to normal working conditions, typically within 10 days of the leak repair. If any of the 2 leak verification tests fails, it indicates that the system is still leaking. In such cases, the owner must undertake further repairs on the appliance.
After leak repair of cold storage chiller system using 2,500 pounds of R123 and a successful initial verification test, we must follow up uh, leak verification test can be conducted within 10 days.
Mothballing an appliance involves evacuating it to at least atmospheric pressure, which means removing all the air from the system, isolating it from the other components, and temporarily shutting it down. Isolating involves separating the appliance or a piece of equipment from the rest of the system. Equipments may be mothballed if the repair process is prolonged or if a replacement piece of equipment is unavailable at the moment.
Which of the following action is not necessary to mothball an appliance using an ozone depleting refrigerant? Temporarily shut down the appliance, remove the appliance and store it in warehouse in the facility. Yeah, this one.
Retiring the appliance involves taking it out of service and properly disposing of it. If a leak is deemed irreparable, retiring the appliance and disposing of it is the appropriate course of action. Retrofitting refers to adapting and making changes to equipment so that it can utilize a new refrigerant. If a leak is deemed irreparable, retrofitting the appliance to accommodate a new refrigerant is a potential solution. In this module, we covered the EPA's classification of systems, including the maximum leak rates for each category. Additionally, we discussed the procedure for repairing leaks in a system.
Leak repair regulations. This in module type 3, module 2.
In this module, we'll delve into the regulations governing leak repairs. We'll also cover EPA regulations and record-keeping requirements following the repair of a leak.
If a technician identifies a leak in any chiller containing 50 or more pounds of refrigerant, the owner or operator must have the leak repaired within 30 days of detection. An owner is the individual who possesses the appliance, while an operator is the individual utilizing the appliance. In addition to repairing the leak verification tests must also be conducted within the 30-day period to confirm the results. These tests include the initial leak verification test and the follow-up leak verification test. The EPA mandates that the follow-up leak verification test must be carried out within 10 days of the leak repair. This follow-up test is mandatory for appliances containing 200 pounds or more of refrigerant. If any of the leak verification tests fail, the owner or operator of the appliance can conduct additional repairs and repeat the process within the 30-day window. If the owner or operator fails to repair the appliance, they must develop a retirement or retrofit plan. The plan must be executed within 12 months. The appliance can continue to operate without repair for 12 months, before which the appliance must be retrofitted or retired. Natural refrigerants like ammonia, R717, and carbon dioxide, R744, are exempt from the venting prohibitions. The owner or operator has 18 months to retrofit or retire a leaking appliance if the replacement uses a refrigerant exempt from the venting prohibition.
How long do owner or operator of an chiller with a full charge of 750 pounds of R123 refrigerant have to retire the appliance if the replacement uses a refrigerant that it is exempt from the venting prohibition? Okay, to retire the application, 18 months, I think. Yeah.
The EPA allows certain situations in which the 30-day deadline can be extended. These may include extensions due to federal, state, or local regulations. The leak repair deadline can also be extended if a component is not available at the moment. To extend the deadline, the owner or operator cannot use a reason that a certified service technician is unavailable.
Which of the following cannot be used as a reason to extend the appliance repair deadline? A certified service technician is not available.
Now that we know the deadlines to be followed while repairing any leak, let us look at some EPA regulations. Record keeping is the task of maintaining the complete details about leak inspections, leak repairs, and the tests performed to verify repairs of leaking appliances. The technician working on the system must provide all the records. As per the EPA, it is compulsory to keep the records for any appliance containing 50 or more pounds of ozone-depleting refrigerant for a minimum of 3 years. The owner or operator of the equipment is responsible for keeping the records.
How long must owner and operator of low-pressure chiller using R11 refrigerant keep the record of leak inspection, initial verification, and follow-up verification for 3 years?
As per EPA, along with other details, the record should primarily include location and date of the recovery, type of refrigerant recovered, total amount of refrigerant recovered, and amount sent for reclamation. The owner or operator should maintain a hard copy or an electronic copy of the document. The records must also be kept on the site where the appliance is installed. Technicians and HVAC servicing companies should also keep records of appliances having refrigerant amounts between 5 and 50 pounds when disposing of them. The disposal records must be kept for a minimum of 3 years.
Who is responsible for keeping records for all leak inspections and any completed leak repair verification test? The original standard technician employed, the technician who performed the inspection or verification test, the owner and the operator of the equipment.
At times, EPA requires the owner or operator of an appliance to record and submit a report about the leak to EPA. A report must be submitted to EPA if the system's leak rate in one calendar year, January to December, is higher than 125% of the total refrigerant amount in the system. A 125% leak rate would mean that the system once leaked completely 100% leak. It was repaired and filled back with refrigerant. A quarter, 25%, of the refrigerant leaked out again. And all of this took place in one calendar year, January to December. The submitted report must describe the owner or operator's efforts to identify and repair the system's leaks. Apart from this scenario, there is usually no requirement to submit a report to the EPA. In this module, we discuss the regulations for repairing a leak and calculating the leak rate. We also learned about the record-keeping and reporting requirements by EPA.
Okay, let's continue the leak repair quiz. This for type 3. Okay, we have here 8 questions. For what period should HVAC servicing company keep record? For 3 years. How long do owner-operator of chiller with a full charge of 750 pounds of R123 refrigerant have to retire the appliance if the replacement using a refrigerant that is exempt from the venting provision for 18 months? How long must the owner and operator low pressure using R11 keep record? For 3 years. How long must owner and operator regulate appliances normally containing 50 Okay, keep record for leak inspection 3 years to determine if the system leaking more than the maximum rate. The EPA allow the use of which method to calculate the fill charge. Calculation based on the power. Calculation based on the components. Which of the following cannot be used as a reason to extend the appliance repair deadline? Certified service technician is not available. In which of the following cases will charging system that contain 50 plus pounds of ozone depleting refrigerant required you to calculate its leak rate? Okay, which of the following cases will charging system that contain 50 pounds of ozone depleting refrigerant require you to calculate leak rate? Following a retrofit, during installation of new appliances, during qualified seasonal when to burn off the system. Who is responsible for keeping record of all leak inspections and any completed leak repair verification tests? Original installing technician, the technician who performed the inspection, the owner and operator. Okay, finish. Submit. Okay, 10 of 10. Okay, so now we finish leak detection and leak repair. This is for type 3. Okay, the next video will finish refrigerant recovery and evacuation and charging and repair and safety for the last video for type 3.